Hi everyone, it's Michael again from the Nautilus Group, here to go over questions 8 and 9 from the Chapter 1 assignment. This will better correlate to the forum post question number, or problem number 4, actually refers to question 8, so we'll take a look at that. So once again, we have the same given information. I won't go over it, but you can watch the previous videos, which I encourage if you haven't, where I explain it a little more. So, question 8, in the scenario in question 6, suppose we increase the capacity of the destination links to 100 megabits per second. Will this increase the throughput between sources and destinations? And we're supposed to select true or false. This is essentially the question in the forum post, but they're asking for you to do the calculations or the work, which we've done in the previous question with 6. So to recap on question 6, K was 10, RS was 100 megabits per second, RD was 1 megabits per second, and R was 0.75. And we had multiple choices to choose. And 1 megabit per second was the answer that we calculated. In order to do that work, step 1, we had to put all the units to the same unit. This was our dimensional analysis. And so we did that. We set it up. We crossed our gigabits per second with our gigabits per second, leaving us with megabits per second, and we calculated a value of 750 megabits per second. For step 2, we were to find the relative capacity for the common link R based on the number of K destinations. This work also doesn't need to be repeated for problem 8. Again, we divided R over K, and we found that we got a value of 75 megabits per second. So step 3, we went ahead and then compared the various capacities in our network, and we found that RD had the lowest capacity. And of course, the explanation for this is that throughput is based on lowest capacity. So therefore, the actual value for the throughput was 1 megabit per second, because that was the value for RD. So let's retake a look at step 3, because this is really where we start to see the difference between problem number 8 and problem 6. And so the first thing is we need to strike that value of 1 megabit per second. And instead, we're going to replace it with a new value of 100 megabits per second. Then, when we do the comparison of our various capacities, notice we didn't have to recalculate or reconvert anything because we already had done the previous work for steps 1 and 2, and that carries over for question number 8. Instead, we now need to compare the capacities since we now have new values. RS is 100 megabits per second, RD is 100 megabits per second, and our common link, as divided out by K number of destinations, is 75 megabits per second. And so when we shuffle things around, we now see that RS and RD equal each other, and that those together, or individually, are greater than the value of R over K. This means that our lowest capacity now lies with the common link. So now as we revisit question 8, we can see that will the throughput between the sources and destinations increase? Well, the throughput used to be 1 megabit per second, and the throughput has now increased to 75 megabits per second. So therefore the answer is true. And question 9 correlates to question 8, and that are, what are the bottleneck links? And again, bottleneck links correlate to throughput. It's where we have the lowest capacity, the lowest flow. And so after adjusting the value for RD, we now see that the bottleneck link is going to be with our common link R. And so we can go ahead and select R as the bottleneck link for question 9. I hope this has been helpful. If you have any questions, comments, feedback, please feel free to make that in the form. Thank you.